Hi guys, so today we have a very interesting question. So it is based on quadratic equation. It's little complicated, but y'all are smart guys. I'm sure you will be able to get this. So to start with, first of all, what we have in the question is to show for this quadratic equation that its roots are real. Real as in, if you find out the discriminant which is equal to b square minus 4ac, that got to be greater or equal to 0. Correct? Second thing that we have to prove is that the roots as in the value of x, the solution for x are equal. Okay? They are mirror. Okay? Images, like if x is 3, the other x has to be 3 too. Okay? So we have to prove that this quadratic equation will have their roots, okay, its roots equal only when a will be equal to b will be equal to c. Means all a, b, c will be equal to each other. So how do we prove this? Let's go ahead and first of all, straighten the sum. Alright. Since I have used the same script for Hindi explanation, which is why this is already solved before me. So if you want to get into that video too, I'll give you the link in the description. Okay. So we have x minus a multiplied by x minus b multiplied by x minus c, and so on and so forth. I have copied this question here, which is equal to 0. So this is a quadratic equation. Let's see how we can come up in the proper quadratic look. First of all, we need to multiply. When we multiply this, we get this x into x, x square, x into minus b, xb, you can write bx also, minus a multiplied by ax is minus ax, and minus minus plus ab. Similarly, we have x square minus xc minus bx plus bc. For this, x into x, x square minus b into, plus x is bx in negative term, and minus b multiplied by minus c is plus bc. We have it over here. Now for this, x into x, x square, this into this is ax minus c into plus x is minus cx, and minus c multiplied by minus a is equal to plus ac. Alright? Having done this, what do? We fetch that there are 3 x squares. We bring it over here. Next, what we find is there are 2 ax's. How? Minus ax here and minus ax here. So we have minus 2ax. We have minus bx here and minus bx here. So minus 2bx. Next we have minus cx. 2 places here as well as here. Okay. So we write it over here. And then we have AB, BC and AC. We write it here. Having obtained this, what do we know now? That we can pull out certain common factors here. What are they? Minus 2 obviously, and x. So we have found our x over here, and the rest part with a minus a plus b plus c multiplied by 2 happens to be its b. Remember? B. This b. Okay. So, and here, this is the entire thing is our c factor in the quadratic equation. This one. A is R3. Now, the work hasn't completed here. So, we have taken values, which are common here, minus 2x, and then we have our C, and now here we go with the real operation. What is this? D. Since D is equal to B squared minus 4AC, okay, we know that our B is minus 2A plus B plus C, okay, and this entire thing is to be squared. This is a square. So this is my B, and within the curly bracket, okay, we have a B which is to be squared, and when we square this, we get minus 2 into minus 2, that is equals to 4. A plus B plus C squared is written simply, okay, in terms of how it was before. This has been, okay, our 4, okay, the fixed coefficient 4, and our A is 3. We have got from here 3x squared. So I sure you know that the coefficient clinging on to x square happens to be our A. So x square has 3. So we have 3 here, 4A, and this is my C, okay, which I have got it from here, isn't it? C is 1 that doesn't have any of the x's, which has got a power of x to the power 0, okay, which is 1. So here, having done this, we need to go further and solve it. First one I showed you, minus 2 into minus 2 is 4, and this simply written as A plus B plus C whole square. 4 into 3 is 12, and this drops down, okay, the way it is. Next step, we know that 4 and 12 have got common factors, which is 4. 4 here also, 4 into 1, and this is 4 into 3. So I pull out 4 here. What remains here is simply this, alright? And what remains here is 3 multiplied by, in bracket, AB plus BC plus AC, correct? Having done this, okay, we swell up this, we expand this. We know that A plus B plus C whole square, okay, is an identity which is equal to A square plus B square plus C square plus 2AB plus 2BC plus 2CA, isn't it? Okay, algebraic identity. I have a playlist of algebraic identity. So if you can just go and watch, maybe you can get down to the identities basics. Here 2 we multiply, so we get minus 3AB, minus 3BC and minus 3AC. Alright. So having done this, we know that these are all similar terms. So can we open the bracket and then try to resolve or try to simplify this? Of course we do that. So we have A square, B square, C square plus 2AB, and this is minus 3AB, which means, okay, we get minus AB saved here. For this, 2BC minus 3BC means minus BC saved here, and 2CA or AC minus 3AC is equal to minus AC. Am I right? So now let's walk on to the next page. Thus we have here 4, which was picked up as common, and inside we are left with A square plus B square plus C square minus AB minus BC minus CA. Remember, we are trying to find out our D. These are all D's. Okay. So we are out to prove that D has got, okay, roots, or the value of D is greater and equal to 0. Greater or equal to 0. Okay. So we do a trick over here. We try and bifurcate 4 into 2 parts, 2 into 2. 1 2 is kept outside, the other one is brought in here. Here, look at it. So which means this entire thing is to be multiplied by 2. we do not disturb the equation. Am I right? So 2a square and 2b square and 2c square and 2 minus 2ab and minus 2bc and minus 2ca results here on further multiplication by 2. Now we distribute a square two places. A square here, a square here. B square here, b square here. C square here, c square here. And provide this respectively to them. A square plus b square minus 2ab is a minus b whole square. A square plus c square minus 2ac or ca is equal to a minus c whole square. Alright? And b square plus c square minus 2bc is equal to b minus c whole square. Correct? Now, why are we doing this? We are doing because we know that a minus b, okay, whole square or a minus c whole square or b minus c whole square, if they are squares, they can never land up being negative. Even if there were negative number over here, when squared up, it ends up being positive. So while this is positive, 2 positive, a minus b whole square would also land up being, okay, either 0 or greater than 0. How? How 0? If b was to be equal to a, it would be a minus a, which is 0, square would give me 0. Similarly for this, a minus c, if a were to be equal to c, then a minus a would be in square as 0. Understood? And if there were other numbers respectively, okay, say positive number 5 minus 2, say 3 square 9. So in any cases, what we find over here is that all of them are positive. This is positive, this is positive, this is positive, this too is already positive. So hence we prove that if they'll end up as either 0 or more than 0, we have our D definitely greater or equal to 0. Correct? So in any case, we have D greater or equal to 0. Have you understood or not? So the first contention was that the roots of the given quadratic equation are real. We have proved just now. The second was to prove that when A was equal to B and B was equal to C, then roots will be equal. Why equal? How do we prove equal? We can indirectly prove if the discriminant is equal to 0, it will mean that the roots are equal. They are mirror images of itself. Okay? So how do we do? Since they have already laid out that A equals to B equals to C, in that case only, we'll have D equals to 0. So let's do it. We know that this is our D. Okay? This is our D, isn't it? This entire thing. So, we have, okay, 2 multiplied by A minus B whole square plus A minus B whole square plus B minus C whole square are D. If A is equal to B, which means can we not conveniently write A minus A, which is equal to 0? If A is also equals to C, then we can write A minus A whole square. And if B is equal to C, can we not write B minus B whole square? Which means 0 from here, 0 from here, 0 from here. So when we square them up, we get 0 obviously. So 2 into 0 is 0, which means our D. Therefore, D is equal to 0. Okay. If the supposition is that if they are equal to each other, A, B and C are equal to each other. So we have proved the second contention too, that since D we found equal to 0, their roots or its roots, because we are talking about one quadratic equation, will be equal. All right. So this wasn't very complicated. You can pause the video and go through the session once more for more clarity, guys. So in case there's still some problem somewhere that you need clarity, do write to me in the comment box. I really would appreciate. Thank you so much. Have a great day. Thank you so much for watching my video, and please do keep a track, okay, for further videos too. Bye bye. Have a great day.